it says for 27, it says to limit the domain. It says to limit the domain so that you can find the inverse function, okay? So I'm going to walk you through it. Let's go ahead and let's just sketch a graph of this first so we know what this picture looks like, okay? It's a parabola. So what would the vertex of this parabola be? 6, 0. Okay, so the vertex is 6, 0. Okay. Actually, you know what? I think I might do this on regular notebook paper. Hold on. It's cool. We're just playing with the bells. All right. So the vertex is 6, 0. And you should be writing this on your paper because a lot of people are saying, Ms. Rice, I don't understand this problem. It doesn't make sense. Okay, so here's that one. There's the line that this is reflected over. So I'm just going to do like a really careful job of reflecting this over that line to see what the whole thing would look like. So I know that this would end up being over here. Okay, that reflected over the line. It would look something like that, right? The vertex of this one would be 0, 6. Okay. That's what the inverse would look like? Yeah. Okay. So the instructions, somebody read me the instructions again. Okay, so that an inverse function can be found. Okay, so this right here is the inverse. Is the part that I drew that was an inverse, is this an inverse function? No, it's not. It doesn't pass the vertical line test. So to make that an inverse function, it's going to be a square root graph, right? Because the original was an x squared graph, so it's going to be the square root of x. For it to be an inverse function, I can only use the top half or the bottom half. I don't get to use the whole thing, okay? So you guys get to tell me which half you want to use because we're doing this problem together. Do you guys want to use the top half or do you want to use the bottom half? You want to use the top half? Okay, so we're going to get rid of the bottom half. We're going to say we're taking this away. And what we did is we just took what was an inverse equation and we turned it into an inverse function. We took away the bottom half and we said, okay, now it's going to pass the vertical line test because now it's just the top half. So now we can say, okay, vertical line test, if we're just using the top, it's only going to touch 1 point at a time. But now it's not a reflection of the whole parabola, is it? What part of the parabola do I have to get rid of? Wait, which part did it reflect? If I'm keeping the top, which part was that? The left became the top? You're folding it over the dotted line. Oh, you're not rotating it, you're folding it. So this part went over here, and this part went right here. See how we're folding it, we're reflecting it, we're not rotating it, we're reflecting it. So the part that we get rid of is this part. Does that make sense? Okay. So the part of the parabola that we're choosing to keep is the right half. We're keeping the right half of the parabola. Okay. So if I want to keep the right half of the parabola, I have to write the domain for the right half of the parabola. What's the domain for the right half of the parabola? The domain of the right half of the parabola is 6, to infinity. Okay. All right, let's read the instructions again. Read the instructions again. Okay, so we limited the domain of the original problem. So we said if the original problem said find this parabola, find the inverse of this parabola with a domain of this, then they'd be saying find the inverse of the right half only. And the inverse of the right half only would be the positive version of the square root. If they said the inverse of the left half only, then it would be the bottom of the square root. So depending on who did the problem, you could have two sets of answers that are equally correct. Somebody could do the right half and get the top part of the square root. Somebody could do the left half and get the bottom part of the square root. Most people would do the right half and the top because most of us default to positive answers. Most of us prefer positive answers. Okay, so now let's go through the steps to find the inverse. What do we do to find the inverse of an equation? Yeah, trade the x and y. And technically this is the inverse equation, but we never write it like that. What do? Okay, square root both sides. And technically when we square root, what should we put in front of a square root sign? Plus minus is what we should put in front of there. So you meant 2 as in it's a square root. It's a 2 instead of a third root. Okay, so now the square root and the squared cancel out. And we said for this particular problem, we are choosing to do the positive square root, not the negative square root. So technically you should always do both, but we chose to do the positive version. Okay, so I'm going to say positive version of the square root equals y minus 6. I am not doing the negative version because the negative version is the bottom, and we chose not to do the bottom. We chose to do the top. Okay, now what do I do? Add 6. Add 6. So I've got square root of x plus 6 equals y. All right, and how do I show that this was an inverse? Okay, now does this blue look like a square root graph that has gone up 6? Yes, okay, so there's the answer.
Wait, so if we have a question like this on a test, do we
It's not.
do the graph?
It's not. I want you guys, so this is information that you need to understand in higher levels of math, and this is supposed to be the first year that we introduce it to you, but it doesn't seem to be something that's heavily tested. Okay. All right, let's look at problem 28. Problem 28 is similar but not the same. It's coming at it from the opposite direction. Okay, so let's think about the square root of x minus 7. Okay, so what is it doesn't have a vertex, right? It has a locator point. So what is the locator point of this equation? 0, what was it? Negative 7, okay. So this graph has gone down 7, and then it looks like this, okay. And so if we think about what the inverse graph would look like, it would be negative 7, 0, negative 7, 0, somewhere over here. And then this one's kind of arching away from the dotted line, so this would kind of arch away from the dotted. It'd be like that, kind of. Does that look symmetric? Did I draw it well? Yeah? And this is a square root. And so what is this going to be? X squared, right? Square root, because the inverse of a square root sign is an x squared, right? Those are inverses of each other, okay? So this is this a positive square root or a negative square root?
That's a negative square.
Wait, it goes like this.
Wait, no, it's positive.
It's positive.
Even
So
though the negative
it's down, it's below the x-axis, but it's the top half. That's a good distinction.
because it's in, even though it's in a negative quadrant, but
Yeah.
if it's in a negative quadrant and going this way, then it's
Yes, exactly right. Yeah. So it has been shifted down, but it's still the top half. So it's positive. Okay. And then which part of the parabola is this? Is it the right side or the left side? The right side. Okay. So read me the question again. What is the question asking?
find the inverse of each of the following. Make sure the domain of the inverse is limited so that it truly is the inverse of the original function.
Okay, so when we find the inverse equation, our inverse of a square root function is going to be a parabola, and it's going to look like it's the whole thing, right? If we just did the equation, we'd be like, oh, it's a whole U-shaped graph. But when we look at the picture, it shouldn't be a whole U-shaped graph, should it? It should only be half of a U. So what we need to do is we need to do the work to find the inverse equation, and then we need to make sure to say, but it's not the whole U shape, it's only half of it, and we need to make sure that we specify which half. It's the right half, and then we mathematically say, this is how we know it's the right half, but we write the domain of it. We don't say, look at the right half of the graph, because if you say that to a mathematician like Dr. James, they're going to say, oh, but where's the right half, you know? We got to tell Dr. James the right half is from this to infinity. You know what I'm talking about? Because Dr. James is the type of mathematicians we're talking to. So we got to make sure we write it formally, because formally is all they understand. Are you clipping your nails right now? It needs it. This is the time. Okay. All right. So let's go ahead and let's find the inverse. What do we do? Okay, so x equals square root y minus 7. Okay, and then what should we do? Add the 7. Okay, so x plus 7 equals square root y. Square it. Okay. So x plus 7 squared equals y. And then how do we show it's an inverse? -1, okay? So we have this. Now, this is a parabola that has been shifted, or quadratic, that has been shifted to the left 7. Does that fit our picture? Yes, okay, so that makes sense. Now, with our picture, we have to say, okay, this is the right half of the parabola. So what do we do to show it's the right half of the parabola? We say the domain is what? -7 to infinity. That's the right half of the parabola. Does that make sense? And if we were talking to regular non-math people, we could just say, oh, just use the right half. But math people are like, I don't understand what right means. Those are words. We use math symbols. And so for math symbols, you say, oh, no, domain, -7, infinity. And they go, oh my gosh, thank you. Numbers are more... No, but we wrote it like this. We wrote it in math notation. And they go, oh, math notation, yes, I'm comfortable. He's the math teacher that's a physicist? If you've ever so I have lunch with Dr. James every day. He's brilliant. He's a brilliant man. But he's very intelligente. And thank you, I am bilingual. And I'm not bilingual. Thank you for the laugh. That was nice. I appreciated that. So some of these things, we can't just say it in common language because we are making sure that we're communicating to like legit math. Yeah, if you were to like come out of my room and turn left and not go down the long hallway, he's like next to Mr. Boyette. So there's 2 math teachers down the hall, and he's down the hall. Say it again. He's got some hair. Ish. He's the only math teacher that's a little bit older. There's only one. Shouldn't be. Okay. So if I were to sketch a graph for 26, can somebody tell me what the vertex is? -3, 0. Okay. So this would be a parabola, a quadratic, right? That has been shifted to the left 3. And it would go up like this. And then I'm just going to draw in the line y equals x. That's the line that we always draw our inverses reflected over, right? Yeah.
We figured it out without using like a graph and all that.
That's fine. That's fine. Yeah. This is just me helping people who had a hard time with it because I got some questions last night saying like, how do I do this problem? And I said I would talk about it today. So if the vertex of the original function for 26 is -3, 0, what would the vertex of the inverse be? 0, -3. So it'd be 0, down 3, it'd be down here. And then if we think about what it would look like reflected over, this part kind of goes up, so it would look something like this. Do you guys see how that would look kind of reflected over? So this over here is the inverse. Okay. It's not perfect, but it looks kind of right. Okay. You guys, are we paying attention? Okay, but we shouldn't be talking. Okay. So this is what the inverse would look like. Now, is the picture of the inverse a function or is it not a function? It's not a function because if I was to do the vertical line test, it would fail it, right? It would touch 2 points at one time, so this would not be considered a function. So if I wanted my inverse equation to be considered a function, I would have to limit my drawing of the inverse somehow. And the way that I would limit the drawing is I would decide to only use part of it. I wouldn't use the whole thing. I would either use the top half of the drawing or I would use the bottom half of the drawing. I'm just going to choose not to use all of it. Are you guys copying somebody's paper? What are we doing? Can we, maybe? Are we writing this down? Because it kind of looks like we're copying a paper. Okay. So do you guys want to keep the top half of the inverse or do you want to keep the bottom half of the inverse? We want to keep the top half? Okay. So I'm going to get rid of this part down here. So once I get rid of the bottom half, I can say this is no longer an inverse equation. Now I can say that this is officially an inverse function. It passes the vertical line test. This is officially good. We're set with that. But now if I'm only using the top half, it's not a reflection of the whole parabola anymore because the whole parabola would have given something that was an inverse equation but not necessarily a function. So if I only take the top half, I'm no longer taking all of the parabola. I have to get rid of half of the parabola as well. So if I think about this being reflected over the dotted line to make this blue part that I kept, which part of the parabola should I scribble out? Which part did I not use? I'm not rotating it, I'm reflecting it. So think about folding in half over the dotted line. The left part. This part I'd have to get rid of because this part reflected over to give you this part. Does that make sense? So if I'm going to say I'm keeping only the top half to make sure that the inverse is a function, then that means my original parabola had to be limited as well. So only the right half of the parabola could have been used. So if we go back and read the instructions again, what do the instructions say? Limit the domain of the original function so that the inverse will be a function as well. That's what the problem is asking you to do. Does that make sense now? Because we could find the inverse of the original problem, but the inverse wouldn't have been a function. So if we wanted the inverse to be a function, that means we have to go back to the original problem and we have to limit it somehow. So now if we limit it and we say, okay, only take half of it, then when you take the half of it and find the inverse is now a function. It works. Does that make sense? Okay. So how do I write the domain to say, okay, only take the right half of that parabola? Yeah.
Bracket -3, comma, infinity.
Perfect. Yep. So you say if the domain of the original problem was -3 infinity, then you're good. If you only take the right half of the parabola, you're set. Now you could have done the same thing and said only take the left half of the parabola, but then your inverse would be the negative version of the equation instead of the positive version. Okay, so now we need to do the work to actually find the inverse. And so this is kind of going back to the biggie assignment that we had, where we actually do the work to find the algebraic equation for the inverse. So what do we do? Switch the x and y. Okay, and then what should we do? Square root it. And whenever we square root, what do we put in front of the square root? Plus or minus. And for this problem, we say, okay, we made a choice that for this problem, we're going to take the plus version because we chose to get away from the minus version. We chose not to use both. We knew if we used both, we would have an inverse equation, but it would not be a function. So we chose specifically, we want to do the plus version. Does that make sense? Okay, so the squared and the square root cancel out. We have the plus version of the square root over here equals y plus 3. And then what should I do? So square root x minus the 3 equals y. And then what do I do to make sure that this looks like inverse notation? Put in a -1. So y inverse equals the square root of x, the positive version, minus 3. And if I look at my inverse, does my inverse function look like a square root equation that has been shifted down 3? Yeah, so that's a good answer. Yeah.
On the test, are we ever going to have to worry about if the square root is positive or negative?
I'm not going to give you a question like this on the test. But the reason we're talking about it is because in Math 3, it's appropriate to start to introduce you to this idea, because in upper level math, it does matter. Yeah, they start to do problems where the domain of the question makes a difference for how you solve it. And so if we introduce it to you now, then later when it does impact how you do the problem, it won't be so shocking. Yeah. Okay, so 29, what does problem 29 say for the equation? Yeah. Okay, so that's the problem, right? So what's the transformation for this problem? Left 5, okay, so it's like this. That's what our graph looks like. It doesn't have a vertex, but what is the locator point? -5, 0, okay. So if the graph that we're looking at here is a square root graph, then we know that the vertex is going to be an x squared graph. If the locator point is -5, 0, then what would the vertex be for the x squared graph? 0, -5. Okay, so we're going to go 0, -5 would be down here. Hold on, let me draw my dotted line to reflect this over. So if this kind of goes towards, it arches towards the dotted line, this one's going to arch towards the dotted line as well. So I can see, like, here's my symmetry for that part. And then this is going to come like this. So there I can see I'm symmetric over the dotted line. So I've got my square root graph. I've got my parabola right here. Okay. So if we compare these, this parabola that I have, is that a function? Okay, now it's a quadratic, but is it a whole quadratic? No, it's only half of it, right? So when we look at this, we're going to say, all right, if we look at the final answer, I'm going to do the work, I'm going to show the math, and I'm going to find the equation of the quadratic, but I want to make sure that when I write that equation, I also say yes, but it's only half of that quadratic, it's not the whole thing. Because we want to make sure that when we write the answer, if we did not have a picture that went with our answer, that we specify it's not all of the U-shaped graph, it's only the right half of it. Does that make sense? Because this was not a plus minus square root of x plus 5, it was just the positive version, because it was a function to start with. Okay? So let's go ahead and trade the x and y so we can get our inverse. And what would be my first step? Yeah, we're going to square each side. So x squared equals y plus 5. And then what should we do? Subtract 5. X squared minus 5 equals y. And get our inverse notation. So here's our equation. Does the inverse look like a parabola that has been shifted down 5? Yes. And then how do we write that this parabola is only the right half? Domain is, yep, only positive, 0 to infinity. So we said it's only the positive values, just 0 to infinity. So whenever we describe that we're only using a portion of the graph, we always use the domain, especially when the graph is split from left to right, because if you said the range was from -5 to infinity, that would include the left and the right side of the picture, which wouldn't really help. It would have kind of helped you with the inverse part of the graph if you said, oh, the range on this one is 0 to infinity, because then that would tell you that when you did the inverse and got the blue part, that domain would be 0 to infinity. But as far as just describing your answer, the range would not help you limit it to the right half only. Does that make sense? Since the range talks about up and down. Yeah, good question. All right, does that make sense for those last 4 problems, how we do those? So again, I'm not going to test you on those. I don't expect the EOC to test you on those. It is possible that you could get a question on like the ACT or SAT that would refer to something like that. But the reason that we're talking about it is because absolutely it starts to show up in your upper level math classes. So classes beyond this, they start to get influenced by things like this where they might cut the graph in half, and so you start, instead of looking at the whole picture, they start to cut it down and look at only part of it. Okay? No, yes, no. Let me look at the schedule. There's a testing schedule somewhere, I just have to see if I can find it. Yeah. Okay, so we're going to go ahead